Okay, so we're solving exponentials using base change. You can also solve exponential equations, which have an x in the exponent, by using logs, but we're not going to do that until later on this year. So right now, this is the only way to do it. To get that x out of that exponent, you have to write the bases as the same. Like these currently have a base of 3. So then that just means this equals that. So x equals 4. They're really easy once the bases are the same. Okay. So let's look at, first of all, a few of the properties we have to be really good at to be able to do these well. Can you do that in your head? N to the 8th. Next one, n to the 8th. Because in a problem where they are being multiplied instead of a power to a power, then this is like n, and this is like n, and there's 6 of those and 2 of those, and when you multiply them, it just makes a big long multiplication, the n to the 8th. You get that? So whenever you're like trying to remember, do I add them, do I multiply them, you can always break it down into little parts and then look at what it should be and then say, oh, that's right, on this kind I just add. All right, moving on. Don't say it, think. All right, give me the A part, Peterson. And the D part, yes? To the 8th, good. So A to the 4th, D to the 8th. All right, next one. X plus y squared quantity to the 5th. Any thoughts on this one? A lot of uncertainty. All right, that's because you probably are thinking, well, I can't just do x to the 5th, y to the 10th. And that's the main thing I want you to know. You can't do that. You can't just go, oh, I'm going to slap a 5 on here, and then 5 times 2 makes a 10 on there, and I'm done. It doesn't work that way. This is different. This is like, here's a really simple example. Remember how I've told you to use a simpler example if you ever want to like try to figure out a problem that you're stuck on? What's 1 plus 2? 3. What's 3 squared? 9. So we know the answer should be 9. But if we do this little thing of 1 squared plus 2 squared, it won't equal 9, will it? Okay, so you can prove just by a little example like that, that wouldn't work. What would it mean? Well, 1 plus 2 quantity squared would mean 1 plus 2 and 1 plus 2 multiplied. And if you've done that with FOIL, remember that? That's kind of weird, but we could do it. Firsts would give me 1 squared. Outside would give me 2 times 1 is 2. Inside would give me 2. And the last would give me 2 times 2 is 4. What do you think I get when I add those all up? 9, so it works. All right. So, moral of the story is this one would be a big, long, nasty answer. It is not as simple as multiplying x to the 5th and y to the 10th. You'd go x plus y squared times x plus y squared times x plus y squared times x plus y squared, and do that 5 times. And there'd be a whole bunch of FOILs you'd have to do, and then you'd have a couple of triples multiplied by each other, which we haven't even done this year, but it would just take a lot of steps to get the answer. So the main thing I want you to know is don't, if it's adding in the middle, don't just slap on an x to the 5th and a y to the 10th and think you're done. It's so common to have this one and have go, oh, that's just x squared plus 4. No, it's not. It's x plus 2 and x plus 2. So it would be x squared plus 4x plus 4. All right, moving on. This, you learned yesterday that I used a little fun shortcut way of saying it, that the things that were negative exponents, people aren't happy. They aren't happy where they are. We can just put them in the other spot. So if they're up in the numerator, you can put them down in the denominator. And these guys also aren't happy, so I can put them down here. And my 4 and my 6 can be simplified to 2/3. So my final answer on this one will be 2/3. These guys weren't happy, and bring them up here. So all my A's are on top now. It'd be A to the 5th. All my B's are on the bottom, and that would be B to the 7th on the bottom. And all my C's are on the bottom, and there'd be C to the 9th. And you get how that works? Okay, one more like that. I'd like you to, actually this would be a lot easier if I could see those numbers. Hold on. I'm going to go to format, there. hit the wrong thing. That's not going to work. That's the right thing. Line style and make it bright green. There we go. Now it pops. I'd like you to try that one. I'm going to pause while you do it. Okay, take a look at what I wrote. What's wrong with mine? It's got all the negative exponents out of there. Yeah, the a to the fourth over a squared can be canceled or simplified. There's a to the fourth is like a to the second is like a. Two of them can cancel. And then I'll have a squared left. So it's 4a squared, b to the seventh, c. And there's nothing on the bottom anymore. Raise your hand if you got the same thing as me. Good. On to, this is a really tough challenge one. It takes too much time. We're going to just move on. You can handle it though. You just basically solve the inside of it. Once you get that all simplified, you'd do the negative, which would make it flip, and then you would square everything. So do it in the right order. It's best to do the simplifying first, and then do the flip next, and then do the power last. It really can be done in the other order. It's just that it's harder. All right, here's base change. What I suggested when we did these before was that you just put a parenthesis for the number that you want to change the base on, and you just put it for both. Now, what's a good base that can make a 3 and can also make a 9? 3 can. So I'm going to put a 3 in here and a 3 in here. But then this really isn't right. 9 isn't 3, but it's 3 squared. And 3 is 3, so I don't need to change it. Or I could put 3 to the 1. All right. So then I've got 3 to the 2x equals 3 to the 1. And then they got the same base. That means their powers have to be equal. So 2x has to equal 1. X would be 1/2. You get that? I'm seeing a fair number of nods. Okay. So I'm going to go on to this one. Set up for me with the parentheses like that. And then figure out what you think it should be. Let's try to solve this one. I'll pause while you do. Will 3 work as a base? 3 to the third and 3 to the 1. I don't really even need that 1 there. But either way, my answer would be 3x equals 8. Because if there wasn't a 1 there, it'd just be an 8 there. So 3x equals 8. X must equal 8/3. Okay, moving on. Fractions. You can still use a fraction in here, or you could use a whole number for the base, whichever you'd like. Figure out what you'd like to use and give it a shot. Okay, so I'm going to show you once using a 3 for a base. 3 to the what would be 1/9? Well, it would need a negative to make it flip, and a 2 to make it 3 squared make it 9. So, and how does 3 turn into 27? 3 to the third. If I wanted to use 1/9 as the base, the nice part is, oh wait a minute, 1/9 wouldn't work as a base. I was thinking I could take 1/9 and put it to some power and make it equal 27, but 9 to the something is never going to be 27, so I'm wrong. That wouldn't have worked. Okay, there's another problem where it does. I was thinking of that one. Okay, so then to finish it, that's negative 2x equals 3. So x equals 3 over negative 2. Doesn't really matter where that negative is. You could say negative 3/2. All right. Let's try one more. Oops, this needs a over 8. There we go. Give that one a shot. This is the one I was thinking of. You could use 2 different bases. You could either use 2, and then you'd use the negative 1, and 2 to the negative third, because 2 cubed makes 8. Or you could use 1/2 as your base. And then how do I get 1/2 to turn into 1/8? Cube it. So this one comes out to negative 2x equals negative 3, which solves to be x equals 3 over 2. And this one is 2x equals 3, and x equals 3 over 2. Either way works. So you can use different bases even. All right, last one to talk about is not that one. We did that the other day. There's one at the end I want to show you. All right. I guess not. That's enough examples like that. So that's it for the recording.